Howdy. So here's what we're going to do. We're going to do 2000 in the year 2000. I've got AP Calculus AB free response question number 1. This is a calculator active question, so you will need a graphing calculator. I have one right here. Doesn't hurt every once in a while to reset your calculator in case you got unless you got a program in there. If you hit second and then the plus button and then 7, 1, 2 will reset the whole calculator in case it's carrying any kind of weird modes or information. So we're going to need a calculator for this probably, especially because it's an area and volume problem. All right, so it says let the region R be the shaded region in the first quadrant enclosed by the graphs of y equals e to the negative x squared. Okay, so that's this one right here. So we got y equals e to the negative x squared power. And then the other curve is y equals 1 minus cosine of x. Y equals 1 minus cosine of x. And it says, and the y-axis. Okay, so the boundary right here, this is R. Okay, it's bounded by the y-axis. On the top, it's bounded by e to the negative x squared. And on the bottom, it's bounded by 1 minus cosine of x. And then it says, find the area of the region R. So part A, find the area of region R. All right, so A, we're going to say area of region R is going to be equal to, and we find area using a definite integral, right? And now the far left of this region is the y-axis, which is where x equals 0. So we know the lower limit is going to be 0, the lower limit is going to be 0. Now I'm going to punch these into y equals. So I'm going to hit y equals, and I'm going to key in. I like to put my top function in as y1 just so that I can remember, assuming there is only one top. So I'm going to put in e to the power of negative x squared. And then for y2, I'll put in the bottom function here, which is 1 minus cosine of x. And if you're using your own calculator, you want to make sure that you are in radian mode. Because if you're in degree mode, because you're in a physics class last period or something, then it's gonna probably be in degree mode. So you want to make sure you're in radian mode. We do everything in radian mode in AP Calculus. And so now we need to find out where these two intersect. Now it's likely that this number here, according to the graph, it looks like it's near 1, but it's probably a little bit less than 1. So we got to find the left side, because our formula for area is you're going to integrate from the left to the right, and you're going to do the top function of x minus the bottom function of x dx, right? Okay, so let's see here. Did it graph both of them? Now let's zoom in here. I'm going to zoom in to that area right there, or maybe I can do a zoom box, and I'm going to just kind of zoom in on that area. Oh yeah, there it is. I see it. All right. And this is kind of what I see. It just drew e to the x. Now it's kind of drawn the 1 minus cosine of x. And so you can probably see right over here, because I zoomed in, over here that's where the intersection is. So I'm going to hit second and then the trace button, which will give me the calculate menu. Option 5 is intersect. And then it says first curve, and in the top left it says e to the negative x squared. Yep, that's my first curve. Then it says second curve, and then in the top left it says 1 minus cosine of x. Yep, that's my second curve. Press enter. Then where it says guess, I'm going to arrow over, put the cursor near the intersection point. I'm going to press enter. And it says that the intersection is at about x equals 0.94194408. So I'm going to go up here, and I'm going to say let b equal 0.94194408, and then I'm going to store this in for the letter B. So I'm going to press second and then mode, which will quit to the main screen. I'm I'm going to press the X button and then press enter, and you're going to see that number, 0.94194408, and it even gives me a couple more numbers, 15. Then I'm going to hit the stow button in the bottom left. Stow, that means I'm going to store that number as a letter. And I have to hit the alpha button, and I'm going to use B, and B is above the apps button. So I'm going to hit apps, alpha apps gives me B, and then I press enter, and now the letter B, capital letter B, is that number right there. So now, because I made a let statement, you know, kind of like let there be light, you know, just boosh, I have said that B is officially this, and now I can put a B up here instead of having to write out the whole number. And so now my top, I got to do top minus bottom. So my top function here is, well, the top over here. And if you're not sure what the top function is, draw a vertical line through the region, and whatever function is at the top of that vertical line is the top function. Well, that's this one right here, e to the negative x squared. So I'll go e to the negative x squared minus the bottom function, and at the bottom of the vertical line is this function, 1 minus cosine of x. Now I'm going to put this in parentheses because I don't want to mess with distributing it right now. I'm really just keying it in the calculator, so there's no point in messing with distribution. And I know I'm at the edge of the screen here, so I'm going to put dx. There's my integral. Anytime you write a number as an answer, and that number is the answer to a definite integral, you have to write a definite integral on the paper. Okay, so you got to have that written on the paper. So now I'm going to press Math 9, which will give me the definite integral. Now I have the updated operating system, so mine actually gives me a picture of an integral. If you don't have the updated operating system, you may want to get it, or if you're in classic mode, it says fnint, you're going to need to look up how to enter the syntax for a definite integral. If it's your calculator, you should already know how to do that. All right, so I'm going to put 0 as the lower limit, upper limit, alpha b, and then watch this. Because I've already keyed in the functions, I can press, there's two ways to get to this. I'll do it the hard way right now. If I hit the vars button and then arrow over to y vars, and then it says function, select the function option, 1, and then I have all my functions, y1, y2, y3, y4, y5, etc., all from the y equals screen. Well, the top function is y1, so I'm going to select y1. Then I'm going to hit minus. Now I'm going to put in y2 because that's my bottom function. I mean, I could just key in the function e to the negative x squared minus 1 minus cosine of x. That's fine. But I just want to show you how you can grab these functions without keying them in again. Vars, y vars, function, and now I need y2. And then over here I'm going to put in dx. And when I press enter, I get 0.59096. Okay? Now, you only have to be accurate to 3 decimal places on the AP exam, and you can round or truncate. I personally like to be accurate to 4, because if I'm accurate to 4, I'm accurate to 3. So I'm going to put 5.5909. I like to truncate rather than round. So I'm just going to stop after 4 numbers and put 0.5909. So the answer to this, so I'll say area. By the way, this is all really scrunched up, but on the AP exam, you know, you usually have plenty of space in the box, but you have to put your whole answer in the box. This let B, that has to be in the box. That's because they're only going to grade things, they're only going to look at things that are in the box. So area of R is equal to 0.5909, and I'm done with part A. That's it. That's all I had to do. I wrote my integral, I did my work in the calculator, and I have my area. So I'm good to go. All right, let's go on to part B then. Actually, I'll do part B over here. I know I have plenty of space on the computer or on the video screen there. So let's do B over here. Part B says, it says find the volume of the solid generated when the region R is revolved about the x-axis. Okay, so this region R is going to be revolved about the x-axis. Here's the x-axis. And whatever horizontal line a region is revolved about, I call that the axis of revolution. The axis of revolution, okay? The axis of revolution. Or I'll call it the A little o r, axis of revolution. Okay, and so what's happening is this is an area, right? And when we accumulate, oh, sorry, that's not how we're accumulating, sorry. But when this area, when it swings around the axis of revolution this way, it's going to swing down, and then it's going to swing back up the back, and it's going to make kind of a weird donut shape that has where there's like a ridge all the way around the top of the donut, and the bottom of the donut is going to be flat. You kind of have to really be conceptual to think about what this shape, this volume, this solid is going to look like. But whether you know what it looks like or not, it doesn't matter, because there's a very simple procedure for finding the area of a revolution of a solid. And that is, if you recall, what happens is this. If you take any point and revolve it around an axis, that's a radius. And it's going to draw a radius like this. It's going to draw a circle. So this is the x-axis. This is the x-axis right here. And the point is revolving around the x-axis at a constant distance. It's drawing a circle. And that circle has an area. And then if we turn it this way, if you stack up a whole bunch of circles, that's going to make a volume. So we're integrating circles. Now, because there's a top and a bottom, because the bottom is not the axis of revolution, we're going to have a hole in that. And so basically the way you do, this is what's called the disk method. The disk method, kind of like a compact disc. It has a hole in the middle, right, or a DVD. So what you do, the formula for that is we would integrate the definite integral of a circle minus a circle. So that's the area of a circle minus the area of a circle. So we're going to do pi r squared, that's the area of one circle, minus pi r squared. And then we're going to put dx, because we're going to relate these radii to x. Okay? Now, you might say, well, pi r squared minus pi r squared is 0. Right, these are different circles. One of them, this one, has a longer radius, and this one has a shorter radius. So I have r sub L, that's a longer radius, and r sub S, that's a shorter radius. So I have two circles right here. Okay? And so what I need, and then we're going to integrate from the left to the right. And it's the same intersection points here, so we're going to use 0 to b again. So the volume here, we're going to say volume is going to be equal to the definite integral from 0 to b of pi and then some radius squared minus pi and then another radius squared dx. So now really the only question is what is the longer radius and what is the shorter radius? Well, the radius always runs from the axis of revolution. The axis of revolution is the center of all the circles, because this is going to spin around, and the axis of revolution is going to be at the center. And so watch this. Here's what you do. Draw a vertical line from your top function and your bottom function to the axis of revolution. So here's a vertical line, and here is another vertical line. One of them goes from the bottom function to the axis of revolution. The other one goes from the top function to the axis of revolution. Now, whichever one of those two vertical lines is the longer line, let's see here, which of these two lines is longer? This one. Whichever of those two is the longer line, that function is your longer radius. And so the longer radius is e to the negative x squared. So we're going to put e to the negative x squared right here. The shorter radius goes up to 1 minus cosine of x. So we're going to put 1 minus cosine of x right there. And now all we have to do is plug it in a calculator, and we've got our volume. All right, so let's see what I'm going to key in here. I'm going to hit Math 9 to get my integral symbol, or integral setup. Then I'm going to go from 0 to b. So I'm going to hit 0, and then upper limit alpha b. It's still stored as this number right here. Okay? Then I'm going to put in pi. Now look, I know that other people do algebraic simplification and stuff, and they pull the pi to the outside. That's fine if you want to do that. I have my way of doing it. Other people have their way of doing it. I like to leave it as circle minus circle, but you can save time by factoring that pi out if you want to. But I don't do that. Okay, that's not my way. So I'm going to hit pi, second, and then the exponent button will give me a pi. Then I'm going to go, guess what this is? This is y1. So let me show you another way to get at the function y1. If I hit alpha, you have to have the updated operating system. I'm going to hit alpha and then the trace button, and that'll give me a menu of y1, y2, y3, etc. I'm going to select y1. And what am I going to do with y1? Well, I'm going to square it. This is pi r squared, right? So I'm going to hit the square button right here. Then I'm going to press minus, and then pi, and then the other function, 1 minus cosine of x, that's y2. Alpha trace y2 squared, hit the square button, and then dx. And now all I have to do is press enter, and the calculator will do the volume. And the volume of this region is 1.7466. Where's my marker? There it is. 1.7466 truncated. So volume equals 1.7466. Okay? All right, that's part B. Done. Moving on. Part C. Now part C says, now this is a cross-section, a known cross-section solid. Part C says that the region R, this region here, let's get rid of this. Probably draw more lines on here though for this. Okay, this region R, okay, is the base of a solid. That means this is the bottom of it, and something is coming up here, some blob with some shape. The region R is the base of a solid. For this solid, each cross section perpendicular to the x-axis is a square. All right, well, to get a cross section means cutting the solid open and looking at the inside. Okay? But we're going to cut it with a line that is perpendicular. That means a vertical line. The x-axis is horizontal, so a cross-section perpendicular to the x-axis is a vertical line. So I'm just going to draw a vertical line through here, and that's just sort of an example of a cross. If I were to cut the solid and then open it up. And what it says is that if I cut it and open it up, the cross-section is a perfect square. Now, it wouldn't matter where I cut it. If I cut it here, if I open it up, it's a square. If I cut it here and open it up, it's a square. Now here's the interesting thing. Because this vertical line is longer than this vertical line, this square is a smaller square than this square. Okay? So basically what we're doing here is to find a volume, we integrate area. So we need area. We need to integrate area. So the volume is going to be equal to the definite integral, and it's the same limits of integration. We're going to integrate from 0 up to b. Okay, so we're going to integrate from 0 to b, and what we're going to integrate is the area of whatever the shape is that they told us. They told us that it's a square, and a square's, the formula for a square is side squared, and then dx. So now we've got our formula. The only sort of confusing thing is, well, what is the side length of each square? Well, I want you to notice something. These lines that we drew are the side lengths. This is, what you're looking at right there, is one of the sides. And what's at the top of the side? Well, the top of the side is e to the negative x squared. And at the bottom of the side is 1 minus cosine of x. So if you recall, anytime we want to get a vertical distance, we do top minus bottom. So this is a top minus bottom again. So the side of each square is going to be e to the negative x squared minus the function 1 minus cosine of x, which, by the way, is what we used for the area. It's the same thing. We use the same formula, top minus bottom, for the area. Only this time, here we go, volume is going to be equal to the definite integral from 0 to b of e to the negative x squared minus the function 1 minus cosine of x. Now, this whole thing, I need to put it in parentheses. Do you see that? You know why? Because what do I have to do to this side of a square? Well, I have to square it, right? Because the formula is not side, it's side squared. Note that I am not squaring the individual things. I'm doing the difference first, then squaring. And then I got a dx. Now all I got to do is plug this thing in the calculator and I'm done. So I'm going to go math 9. And I'm going to go from 0 to alpha b, okay? And now, I'm going to put a parenthesis first. Then this is y1. So I'm going to go alpha trace, and I'm going to grab y1 minus. And then this function right here is y2. So I'm going to go alpha trace y2. Now I need to close the parenthesis. So what I have is, inside parentheses is y1 minus y2. That's this distance right here, y1 minus y2. And now it doesn't matter what x value I'm at. As the x values get larger, that value of the side length is going to get smaller and smaller until they intersect. And we're stopping there anyway with the integration. But I have to square this. In order for it to be a square, the area of a square, I need to square the side. So I'm going to put a square in, and then I'm going to go put an x under the dx. So I have the definite integral from 0 to b of the quantity y1 minus y2 squared, then dx. I press enter, and I get 0.4610. And because it's 0.4610, I'm not going to put the last 0 on. Volume equals 0.461. And that's it. And we're done with this question. Let's see how long it took me to explain all this. Because you have about 15 minutes per question. Well, that probably took about 20 minutes. But, I did a lot of explaining. When you're actually doing it just by yourself, it probably shouldn't take 20 minutes. And, the more you practice these, there's lots of them. Over here, I've got the 2001. The very first question with a graphing calculator, again, find the area, find the area, find the volume. They usually have at least one of these on every AP exam, where you find area, you find volume. You find a volume of a cross section, you find a volume of a revolution of a solid. Okay? Well, that's all I got for you, and good luck. And I don't know, send me an email or something if you have any questions.